linear equation with constant coefficients. This part is divided into three. First, we have the auxiliary equation with distinct roots. Any linear homogeneous differential equation with constant coefficients, like for example this equation, that is a sub 0 and derivative of y with respect to x plus a sub 1 and minus 1 derivative of y with respect to x plus dot 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 plus a sub n minus 1 dy over dx plus a sub ny is equivalent to 0 may be written in the form of f of dy. This is our differential operators. Now, if we have this kind of equation, differential equation, which is linear homogeneous differential equation, then our way of solving this one with distinct roots is y equals c sub 1 e raised to m sub 1x plus c sub 2 e raised to m sub 2x plus dot 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 plus c sub n e m sub nx. In other words, this is our solution if we have here our linear homogeneous differential equation. When we speak of linear homogeneous differential equation, you have here your nth derivative of y with respect to x, and then that is in descending order, and then you have here your constant a sub 0, a sub 1, and so on. Okay. Now, to understand how to use this equation, we will have here our example. Okay. Take note, the auxiliary equation with distinct roots. So, we have solved the equation, third derivative of y with respect to x minus 4 times the second derivative of y with respect to x plus the derivative of y with respect to x plus 6y equals 0. Now, to solve this one, we will write its auxiliary equation. Now, its auxiliary equation, we use m. So, we have m. This is now our solution. We have here, okay, m, this is raised to 3, so this is m cubed. And then 4 m squared, and then plus m plus 6, okay, which is equivalent to 0. So that is now our auxiliary equation. Okay, so for this auxiliary equation, we have to find its distinct roots. Now, to find its distinct roots, we will make use of synthetic division. Okay, so synthetic division, if we have here the coefficient of m cube equals 1, so we will write here our synthetic division. We have here 1 minus 4 plus 1, and then we have here 6 plus 6. We will no longer write positive sign. And then our factor of 6, we have 6, positive 6, and negative 6 times positive and negative 1. Another factor of 6 is 2 and 3. So we will try some of those factors, and then if we do the synthetic division, we have to make sure that on this part is equivalent to 0. So take note, our factor of 6 can be 6 and 1 and 2 times 3. So let us try positive 2 as one of its factor. We will write here positive 2, and then we will make use of positive here. So plus 1, bring down 1. 1 times 2, that is positive 2. Negative 4 plus 2, that is negative 2. And then negative 2 times 2, that is negative 4. And then 1 plus negative 4, that is negative 3. And then negative 3 times 2, that is negative 6. when you add this one, that is equivalent to 0. Therefore, one of our roots here, m, is equivalent to 2. So this is now one of our roots which is equivalent to 2. So we will write here as m sub 1 as our first roots. Take note, this is m cubed, so it is expected that we have 3 roots. So at this time, we have solved already our first roots, which is m sub 1 equivalent to 2. Now let us try to solve m sub 2. Take note this one, if this synthetic division is based on this equation, m sub m cubed, then this time, this one is m squared. This is equivalent to m squared minus 2m minus 3. That is equivalent to 0. Okay, so again, we will make use, or you can factor this one if you want to factor this one, or you can make use of synthetic division again. But in my case, we will do the factoring here. So I will write it again here. We have m squared minus 2m minus 3 is equivalent to 0. Factor of 3 is 2 and 3 and 1. So we will have here m minus 3 and then m plus 1. Okay, which is equivalent to 0. Take note, negative 3 times 1, that is negative 3, and then negative 3 plus 1, that is negative 2. So this will be our factor. So that for this case, we have m minus 3 is equivalent to 0. For this part, m plus 1 is equal to 0. So for this case, our m here, we will transfer 3 to the other side, that becomes positive 3. This will serve as our m sub 2. And then this one, we have your m is equivalent to this one transferred to the other side, that becomes negative 1. This will serve as our m sub 3. So take note again, this is m cubed. So it is expected that we have 3 values of m. We have m1, 2, m2 equals 3, and m3 equals negative 1. Therefore, we will now write the solution using this format. So our solution for this problem, we have y that is equivalent to m sub 1 is 2. So we will write here c sub 1 e, our m sub 1 equals 2, and then x. Next, we have plus c sub 2 for another roots, c sub 2, and then e raised to, this time your m sub 2, which is 3x, and then plus c sub 3 e raised to negative 1 times x, so that is negative x. This will be our solution for this differential equation. We have another example. We have solved the equation 3d cubed plus 5d squared minus 2d times y equals 0. So if you have noticed this one, this is in differential operators. Okay, so we have to solve this one. Take note, this one is the third derivative of y with respect to x. This one is second derivative of y, and then this one is first derivative of y. Now, to solve this one, again, we will write its auxiliary equation. So this is 3. We will write this auxiliary equation. We have here 3. 3m cubed plus 5m squared minus 2m, which is equivalent to 0. Okay, so minus 2m is equivalent to 0. Take note, you have here a common factor, which is m. So we will factor that m. We have here m times 3m squared plus 5m minus 2, that is equivalent to 0. So if you have noticed here, you have here the value of m, the first value of m, that is equivalent to 0. So here we have here m is equal to 0, and then the other equation we have here 3m squared plus 5m minus 2. That is equivalent to 0. So we have already the value of m. Will be our m sub 1. Take note, this is m cubed. So we have here our first value of m, which is equivalent to 0. And then this time, we have here this one. We can make use of factoring for this part, or you can have, I will make use of synthetic division. So in synthetic division, so there are many ways to solve that problem. We have here 3 and then 5 minus 2. Okay. Then factor of negative 2, let's say negative 2. That is negative 2 times 1. So we will try this one. Okay. For a while, I have to erase this one because the line is not so good. So I will draw another line. So we will bring down 3. 3 times negative 2, that is negative 6. 5 plus negative 6, so we will make use of positive here. That is negative 1. So that negative 1 times negative 2, that is positive 2. So this is now equivalent to 0. Therefore, we have the value of m here, which is equivalent to negative 2. We will make this one as our m sub 2 because we arrive here as 0. So we can declare that this one will be one of our roots. If this is not 0, then we have to change this one. Okay. So we have already m sub 1, we have already m sub 2. If this is 3m squared, then this is 3m minus 1. That is equivalent to 0. So that when you find the value of m, which is equivalent to, transfer 1 to the other side, that becomes 1 over 3. So this is now our m sub 3. We have 3 values of m sub 1, m sub 2, and then m sub 3. Because this is m cubed, so we have 3 values of m sub 1, m sub 2, and then m sub 3. Now, once we find the roots of each equation, then we can now use this formula to solve this particular problem. So we will make use of y. That is equivalent to c sub 1 e raised to our m sub 1, that is 0, so 0x, plus c sub 2 e, our second value of m, which is negative 2x, and then plus c sub 3 e raised to 1/3 x. So that this one e raised to 0x, that is equivalent to 1. This is equivalent to 1 because any variable raised to 0, that is equivalent to 1. Therefore, our final answer is c sub 1. We have here our c sub 1 plus this one, that is c sub 2 e negative 2x plus c sub 3 e negative 2x over 3. That will be our final answer. Another example, we have here the second derivative of x with respect to t minus 4x is equivalent to 0 when t equals 0, x equals 0, and then dx over dt equals 3. So we have here a given condition of t and x, which is equivalent to 0, and then dx over dt equals 3. Okay, so again, when we solve this equation, we have to write its auxiliary equation. Now, when we write the auxiliary equation, then this is equivalent to m squared minus, okay, so m squared minus 4, which is equivalent to 2. And then if 4 is transferred to the other side, that becomes m squared is equivalent to 4. so that m equals the square root of 4, which is equivalent to positive and negative 2. So we have two values of m, our m sub 1, which is equivalent to positive 2, and then our m sub 2, which is equivalent to negative 2. Now, once we find the value of m sub 1, m sub 2, of course, we will now write our equation, this one. So that you have here y is equivalent to our c sub 1, c sub 1 e raised to m sub 1x, m sub 1x, that is 2x, plus c sub 2 e raised to negative 2x. Okay, so by the way, we're using the variable x and t. So if we use variable x and t, so this is no longer x, as well as this one. Sorry, so I have to change x, and then this one now is 2t, and then this one is negative 2t, because we are using the variable x and t. So that this one, x equals c sub 1 e raised to 2t plus c sub 2 e raised to negative 2t. So since we have the value of t equals 0 and x equals 0, so we will write here when t x, when t is equal to 0, then our x, okay, our x now, let's say x is equivalent to 0, e to the 0 equals 1, so this is now c sub 1, and then this is e, 2 times 0 equals 0, e raised to 0 equals 1, 1 times c sub 1 equals c sub 1, plus our, this equation, when we substitute the value of t as 0, then this is e raised to 0, which is also equivalent to 1 times c sub 2, then that is equivalent to c sub 2. Okay, so take note, we will make this one as equation 1. We will make this one as our equation 2. Now, another given here is dx over dt. So if this is our x, then we will take the derivative of what this equation. So we have dx with respect to time, dx over dt for this equation. So derivative of this one, that is 2c sub 1, 2c sub 1 e raised to 2t. And then this one, the derivative, so that is negative 2. So minus 2 c sub 2 e negative 2t. This time, when dx over dt, okay, given dx over dt is equivalent to 3, and also our t is equal to 0, then substitute the value of dx over dt from this equation. We have here 3, which is equivalent to, again, this one is e to the 0 equals 1 times 2c sub 1 equals 2c sub 1, minus, again, also this one, when t is substituted as 0, so this is 0 times 2, that is 0. So e to the 0 equals 1 times 2, this is c sub 2, minus 2 c sub 2. So we will make this one as our equation 3. This time we have two unknown variable, which is c sub 1 and c sub 2. We need, if we want to find the value of c sub 1, c sub 2, then once we find the value of c sub 1, c sub 2, we will substitute that value to this equation. So we have to combine these two equations 2 and 3. Okay, so by the way, this one, when x equals 0, so substitute for number 2. Okay, so by the way, this one, this is no longer x, but instead, so we have to change this one into 0. Okay, so 0 when x equals, when t equals 0, and then x is also 0, I will write here x is also 0, which is given in our condition, x equals 0, so we will substitute, instead of writing x, we have here 0. Now we have to combine equation 2 and 3. and then we will eliminate one of its variable, I mean constant. So for this case, I want to eliminate c sub 2. So I will combine equation 2 and equation 3, and then multiply 2 times equation 2. Okay, I will multiply 2 to equation 2. So multiplying 2 by equation 2, we have here 2 times 0, that is 0, and then equals 2 c sub 1 plus 2 c sub 2. And then our equation 3, that is 3 equals 2 c sub 1 minus 2 c sub 2. We will add these two equations, so the result will be, we will now eliminate c sub 2. So this is 3 is equivalent to 4 c sub 1. Therefore, our c sub 1, that is equivalent to 3 over 4. 3 over 4. Now, once we find the value of c sub 1, then we can make use of any of this equation to substitute the value of c sub 1. So if c sub 1 is 3/4, then from equation 2, we have here 0 equals our c sub 1 from equation 2, that is, we will substitute c sub 1 to equation 2. That is 3 over 4 plus c sub 2. Okay, c sub 2. Okay, wait. I will change this one. Okay, so we have here 3 over 4. Therefore, our c sub 2 for this case equals, we will transfer 3/4 to the other side, that becomes negative 3 over 4. Therefore, we have our c sub 1, c sub 2. So from this equation, we will substitute the value of c sub 1 and c sub 2. So again, from this equation, we will write it here as x, which is equivalent to, instead of writing c sub 1, we will substitute it as 3 over 4. 3 over 4 e raised to 2t. And then, plus c sub 2. Our c sub 2 is negative 3 over 4. So negative 3 over 4 e raised to negative 2t. This will be our final answer.